Okay, so now the first step for us is to read the library. So the library with raster and also the RS toolbox. This is the required libraries now. You are following the install. If you don't have those libraries, you need to install first, install package, then read the library. If you use the library that I will upload, then you can just read the library, give the link as I defined here based on your system. Just put this library somewhere and read it. After that, everything will come normal with you. Okay. Now I need also the study area. Why? Because also we need to clip inside the R. So later on you will get everything ready without need to do any process by yourself. So the study area, that the study area focus, if you remember here, this one. Okay. Try to find it where we where is the location of it. This is the location. Can take this path. Okay, and copy the link location, and you come here to the shapefile. You see here, you can just copy from here, take the G and the shapefile, and you can paste it here. Similar. Okay, this is easy for you. Instead of typing everything, just copy and paste it here. Okay, so study area. Now this is the first variable. Now we have, if you want to plot it, so we have our study area here. So we have our study area, and they have all the information. Here you have the projection and so on. Okay, so now we start with the 2006. Again, we said we will use just 2017, 18 and 19, so you can ignore the 2016. Okay, you can start with 2017. Sorry, it's the same actually. It's just my study area. For you, you can do whatever you like. Yes, we know first. Let's come with the first line. You can ignore the previous text. This one I will delete it for you, just as if start from the 2017. So now you have your working directly. No need to do this, just to check. In case if you don't have this, and you are just using the old style, you can just copy the working directly address. Just copy this one, copy, Ctrl+C, and follow this code. Just copy, and after that run this code. It will take also the working directory for you. It's a piece of code that sometimes you need to change this slash to the backslash, and you get an error, and maybe your address is very long like this one. This isn't like an old skills. So if you like, you can just copy paste the address from here, take your working directly, and then run this line. It will give you also same result. For us, we already defined in here, so already we have the working directory. Okay, again, so we have this one already we did, shapefile. Even if you do it again, nothing happened because it will just change it. Now we want to read the June 2017. In the June 2017, we have our scenes. So let's see how to get this scene into the R. First, we need to list the directory, what it's inside this directory. And you should add the the folder actually you see, this is the files, this is our working directory. See here, so this kind of folders exist. So our data, it's here inside this, so you can just write list directory. Either you write it or just put the point, one point backslash the folder, run it. It will give you all the folders that inside of here. Okay, so you can do it in this way. So just put point and the backslash, that's when you are going to one folder. Now we want to list the files inside this scene, the scene of 2017 June. Don't look here, don't get confused. This is, as we said, here you are dealing with the download of it. For you, this is important. Okay, this is the important 2017 June. Okay, please list all the files that inside the 2017 June scene, which is from bands, different kind of bands. But what I choose only the metadata file, because I give the pattern as text. So I don't want to list everything, just I list the pattern of MTL. This is the pattern. This is the metadata, which it contain all the constants, it contain everything about the information about the scene. If you want to see it, 2016, this one. Okay. You have two metadata, two text, this one that we need at the end of MTL. Open it, you will see that you have the information about the scene, information about the settings, about the bands that you have already here, the same, the names listed inside here. Also you have the saturation of the bands and geometric, root mean square error. You have the radiance minimum, maximum for every band. So all kind of information provided by the satellite. Also the datum, you see the zone, we are zone 38, north of Iraq, UTM, all the information exists. Okay, so for you, the code will automatically read all of the sort of the information. So I want to create variable for the metadata, read the metadata that already here. So but just make sure when you run this one, to copy this one, copy and paste it here. This one. Okay, this is copy and paste. This is what you need to, because for you, your data has different names, different scenes, and different code. So because here you have just only every scene, you have just one MTL. Take this MTL and put it here. Okay. Now we have the MTL. If you want to read it, Control R I'm using. So you have all the information inside this meta June 2017. Okay. So now we want to have the stack of metadata, which is, it will simplify the code for us, the metadata. So you just stack meta, run it, it will stack. So if you want to read what we did here, just, you see, it's make the things more like raster. So it's as if it's make it as raster with stack, raster stack, it as if it's stacked all the bands inside, but actually it took the signature and didn't take the original bands. It's not scenes, there is no scenes here. It is just stack the raster signature. How much is this is the digital number. What does it mean? That means it's before the geometric or radiometric correction. It's just the raw data. This is the raw data with the extent. Also, this is Landsat, so it's 30 by 30. So what does it mean here? It's stacking the bands to able to run the function, run the mathematical equation. Okay, and we continue. Here we need to find the haze digital number, which is the Landsat 8. It's from here, and the haze band 1 to 4. It's all about the code. It's written in the way that help you find the Landsat temperature. So also the haze, can find it here, and also then after running this one, you will find radiometric correction. It will do under the Landsat 8 SDOS. It will fix the radiometric correction. Until this process finish, we will just move with the land surface temperature. Actually, this radiometric correction for the haze value, we need it inside our equation. And as we said, you need any further information about this equation about the spectral indices, just go to the link and follow the explanation comprehensively. But here we just try to run the code as fast as possible, and it will be in your hands to follow it and verify it with different resources. It took like 5 minutes. That's why I stopped the record and I came back. So now we got the value of the haze for the June 2017. Okay, and now we want to do the radiometric correction. I hope it won't take also time. So worth to mention that we will do the same procedure for the June 2017, July 2017, August 2017, and then again June 2018, July 2018 until 2019. 3 months, 3 months, 3 months for each year, and then after that we will take the average of it. Just worth to mention here, if you look to the RAM and the processor, this is very important that you keep your eyes on the RAM, because some students, they get failure in the run and they try to search the reason. Actually, the failure that you don't have enough space for the RAM. You see now within this amount of data that we have, the variables that we define, our RAM, the temporary memory, is getting to 65. So it's better for you if you have any sort of Windows, try to reduce the memory. So I close the Chrome. See, it's okay, we got 10% less. But also I will show you something more effective now. Now let's calculate the land surface temperature. So now for we need the Ndvi as we show in the equation. So the Ndvi, it will be also input from the radiometric correction of the haze. It's also depend on the band 4, as you know, and band 5. So Ndvi, it's a relationship between band 5 and band 4. Now they will calculate the Ndvi, and then we still have some inputs about the PV. Okay, this is run good, so you can check. So the Ndvi, as you know that we have the Ndvi from -1 +1. Okay, so this one we have like from minus 0.5. It's fair enough. You know, -1 to 1 maximum green, and -1, and you will get the 0 within the water. So this is specification of the Ndvi between the green cover and the dry land cover. So now we will take the BV. This is also one of the needs for the run of the land surface temperature, which we said here, the Planck constant. Okay. The Planck constant, we define it, and then the emissivity calculated after that. See the electromagnetic emissivity and proportion of vegetation, we call it. It's built on this formula, and it's also written in the website that I showed. So everything translated from the equation into here. So you can just follow the code with all of those constants and look to your previous page, and you say that all of these units, it's here, but it's just written in a different way that the R can understand it. Okay, now we go to the E value. Now BV, we found the BV. Now the E value. Okay, now the last step, it's the temperature. So this is the temperature of June 2017. You want to double check, it's started from 7 to 97. If you remember, when we opened the scene, it shows also some very high temperature because of the roofing, also on some temperature very low can be also found, but most of the data was between the 7 and 90, between 30 to 45. If you want, also you can plot also this raster, and also you can see the temperature. But now, before we plot, let's mask it based on the study area, then we can make it smaller. So Landsat, the June 8, 2017 with mask. So we will apply the mask function, and it will crop with the study area. Okay, so now June 2017 done. You want to plot it. Yes, very easy. You can see we don't have something within the dark green, so always the results zoom in between the 40, okay, between the 40 till this value, most of this steady area. Here you can see the cold because it's all lakes, and here part of the stream also seems cold. Okay, and some of the area that you see the dark is almost here. When you come to these zones, that it's a little bit more hot, because in Iraq usually in June, expect June and July, it's the hot weather. So this is fair enough. Also you can take it to ArcGIS, to the QGIS, and verify. So we will continue July in the same manner. We will list the directory here again, and based on the scene that it's follow the July 2017. Where is it? It's the one that 2016, 2016, 2016, 2017, 2017, July. So you will take all of this, you will copy it, and you will paste it. One zero three two 1032. Paste all of this, and then choose the MATL to give you the text file, the meta. Okay, so click here. Yes, we got it. Then you copy this one again and you paste it here. This is the result. So this is the metadata of the 2017. July. Now again you will run the Landsat 8 July stack. You stack it. Now the haze digital number. The haze also work fine with you as it worked previously. And just worth to mention that the metadata for the entire scene, it's similar. Also for the different months, also similar. There is no much difference as I noticed. Okay, because the specification of the scenes and the satellite also constants, all considered to be constant, referring to what we are using now. Whatever we are using now, almost it's constant. There is no much differences, but I like to make the things systematic that you don't get confused with maybe short coded. You see, I arrange it to make it as every month. So for you, you want to have different months, easily you can adjust it. But if I put all together and make it shorter, maybe it will be for some intermediate or beginners, it might be difficult and complicated. In this way, I think it's very easy, very simple to follow. Every month in every year, it has its own lines, and it's not too much. We will just go through, and you can just run it without changing anything. Just change your folder and metadata, and then it will give you everything systematically. Also, I will stop after that the record, and I will run the July and August for 2017, and then again June, July, August for the 2018 and 19, and then I will come to you to tell you about what need to be done. Just let us reach until the August 2017. Why is that? I just want to tell you that if you want to save, you see now the memory start to get more, and imagine after August and 2018, I think you will lose your memory. So it's better to do what? It's better that after you get the result of the Landsat land surface temperature of 2017, save it. Save it, and then you can delete everything earlier. You can clean the memory, because that's what's important now, to get the mean value of the 2017. Okay, this is what we look for. We said 3 months, we take the average. 3 months, we take the average. After that, we have every year one scene. So 3 years, we take the average of 3 years. So this is what I am going to. Let's just run everything all in the same time. We stopped here, the haze. So we just make like this. This is for the July 2017. Also, I want to mention that you don't have to change any of those constants. Any of those constants already there and they are fixed. So for you, you have nothing to do with the code. Just the MTL and the scene name. Change it. The others, nothing to do with it. It's taking some time now. I hope before we get our RAM filled, we can finish just to reach until saving the raster. You are looking at the RAM with me, I think, on the right side of the screen. I'm putting this to just to manage to see the RAM. Okay, so we have the last month, August. So let's run it together all. This one we know the directory, and then metal, giving metal. After that, stacking everything together. Take the A's, run the Ndvi PVE. After that, LST. LST we need to crop it until here we discussed this. So let's run it together. After that, we have to take the mean value of the 2017 because already we have 3 months now. So how to take the value of mean? We will put calculate stack, also because we want to stack them all together. Calculate function, the Landsat June 2017, July and August. And what is the function? It's the mean. Okay. Try to follow this. Actually, you will have maybe you have a problem if you don't put the calculation inside the stack. You should be stack in the calculation. If you want to make 2 steps, first stack after the calculation, it's fine, but try to make it shorter as much as you can. Some people they run all this code within like half of those steps, and we know, but it will be, as we said, sometimes difficult to follow. So in this case it's easy. Now you can just follow to run the mean and the function of calculate, and then we define the raster, save the mean 2017 land surface temperature. Already I did it, already I found it before you because I did this exercise. What you can do, you can just write raster, you have the mean, give the extension. Actually no need to write this as we said, you just put point, you can write it as you like. And here you have the new TIFF name, mean 2017. Okay, this is your, after the working directory, which is the, you should put LST average. This is the new folder that you will create. We'll show you here. Inside this, I just create something called LST average. So see, LST average 2017. It's almost 20 megabyte. Give the mean 2017 and the format geotiff. Overwrite true. Why? Because in case if we have old file having the same name like me now, you can overwrite and it will replace it without any harm. That's the point of the overwrite. So you won't have a problem with the stack that if you already produce something, it will just overwrite the previous file without asking you. Okay, almost done. We see the RAM not going beyond the 75. Now it's reached to the 80. Actually, if I close some applications here, I will get more RAM. But what I want to do, I just want, because also I'm recording, so the record also takes some RAM. I just need to reach to this step, and then we clean our working directory. We clean it, then we start with another year, and it will also clean the RAM, and we can finish our processing easily and without pressing too much on the RAM or taking extra space from closing some. Maybe you are using some documents here, no need to close them. Follow the RAM capacity. Okay, so almost done now. Now it's here. Okay, this is done. And Ndvi TV run run LS for the August done, and then clip or mask with the study area also. This is the equation. Worth to mention, if you do this equation, actually you can, I did it all manually inside the QGIS and it's possible, but imagine if you just do one scene, it will take too much time just to process one scene, but we process now everything here easier. So you can just run everything while you go and take your coffee or something, come back, everything done automatically. So until here, it's done. So we want to take the mean now to calculate the mean with you. Run the mean 2017. Now it took the mean value. So now you have the mean. If you want to plot, it's the mean of 3 scenes. Plot and take the 2017. Yes. This is the mean of the 3 months inside the 2017. So now I want to write it down, save it, and then I can clean everything before. Okay, done. So you see, it's now just change it. So now it's the new value. This is the value, just we run it just right now, and this is my old results. So you can move on the same way, 2017, 19 and 2018, and you get the mean value for every year. So now as you finish this step, what you can do, save it here, save the code. Maybe you did some changes. Okay, actually we just added this, so I don't want to disturb it, but it's fine. Just save it. And here you can clean now. Clean this. No need to use anything from the previous code, from the previous variable. Just clean this one. Now just see the RAM, how much it will enhance. Now 79. Clean it. So now after we clean the RAM, don't have anything to do here. So you can just restart the R. Okay, that's all. We just restarted, and you see it's restart everything, restarting our session. We have the code, nothing here, and also we earn extra space with the RAM. So we can start to process with 2018 safely now. Okay, now after we run the rest of the data, we reach to have, as we mentioned here, we have now the 2017, 2019, 2018. Okay, so far so good. Now what we need, now we already restarted our project. So whenever you restart, actually make sure to read the library, because even the library now it's restarted. Just go to the library and restart the library, reread the library, sorry. Now library is here. Come back to the code, make it easier for you. Just delete this. Make sure that the code for you ready. Yes, you have the libraries, you have everything. So we'll start from the 2017, and I will put this one as archive. That's mean for you, no need to follow anything in the archive. Okay, move on. Now we want to find the average of the 3 years. Average of the 3 years. Come to our directory now. We see what we have. This is whatever we have inside the working directory, and it's here. All kind of the directories inside. So we want to list the files inside the land service temperature. This is the LST. What we have, you know that we have 2018, 2019, 2017. So I want to read them again because I already cleared my environment. Read it, mean 2017. Yes, it said need raster because yes, we didn't read the raster. As I said, you should read the rasters or libraries whenever you start anything, when you restart the session. Okay. All right, so now we read it. The mean 2017, mean 2018, mean 2019. See, just now it's here. This we have just three variables. Now, in order to put them together, let's just check the extent. Sometimes also you have problem with extents that are not matching, or there is some. But if you follow the steps, that you never face any problem, unless if you have some different data you brought from different place and you put it together. Yes, it might have different extent, but so far the satellite image provided from USGS, they're all having one scenery. It has everything similar inside. They clip it very well. So we follow all the, but because of stock, very sensitive to any difference in the Y or X axis. So we stock now the 3 years to find the mean. Back. Now find the mean. Calculate the mean of 3 years. Okay. Now you find the mean, LST average. This is what we have now. See, LST average, mean of the 2017, 19, 18. Right raster is the name. It's okay here, name, this should be similar, but here you can write whatever you want. On this one, now we found it came here. Actually, this one, the mean value of 3 years, it's the same one I did it also before. I rename it because I need it in the processing later. I need just very short name, otherwise this will make some headache for me. So this is the result that we got. Now we found the mean service temperature for the 3 years. Okay, so okay, we are done with the land service temperature. Now we want to find the indices, the other indices from the Landsat 8 bands.